Alright, this is the beginning of section 2.4, solving linear systems algebraically. And for these systems, we will use substitution or elimination to help us solve them. Okay, let me get this off the screen if I can. Okay. Alright, we're going to use substitution or elimination. In this first one, it's going to be by substitution. Now remember to use the method that is asked for. If you don't want to, if it's like number 3 here where it says choose an appropriate method, you can pick which method you want to use. But on this one, with substitution, you look for a variable that has a coefficient of 1. And so you have, for this first equation, you're going to make it equal x or y equal or x equal. Well, you solve for the variable that has a coefficient of 1. So our original equation is x minus 2y equals 5. We're going to add the 2y across, so we get x equals positive 2y plus 5. Okay, and that's step 1. Step 2, you go to the second equation, which is 4x plus 3y equals 9. And then you put in for the x this that you solve for. Now if you solve for y, you would put it in for the y. But in this case we solve for x. So you substitute in, instead of x, 2y plus 5 plus 3y equals 9. Distribute your 4, so you have 8y plus 5 plus 3y equals 9. And then 8 and 3 is 11y. Okay, subtract the 5 across. Oh, that should be, that should be 20, because I need to distribute the 4. Subtract the 20 across, and so 11y equals negative 11. Then for step 3, well, we find out here that y equals negative 1. We need to finish that. So the y of our point is negative 1. Now we go back to our first equation, x equals 2y plus 5. And we figured out what y was, so now we can find out what x is. We have 2 times y is negative 1, so you put negative 1 in for y, plus 5. X is equal to negative 2 plus 5, so x is equal to 3. And that is the solution for this system. With elimination, what you have to do is make the coefficients for either the x or the y equal and opposite. And you can do that. Sometimes you look and by inspection you can see that they are already there, but many times you have to multiply by a number all the way across. For example, 4 times 2 is 8. So if we multiply this second equation by negative 2, then what we end up with is 12x plus 8y equals negative 8, and we have negative 6x minus 8y is equal to negative 4. Okay, then we're going to add these equations together for elimination. 12 minus 6 is 6x. 8y minus 8y is 0. So that's what we've done. We've eliminated the y variable, and that equals negative 12. Now dividing by 6, x is equal to negative 2. So we go over here and our x is negative 2. We have to figure out then what y is. So we go back into one of our equations. I'm going to pick the first one. So I have 12 and I multiply by negative 2 because I know what x is, plus 8y equals negative 8. So that's negative 24 plus 8y equals negative 8. When I add 24 across, 8y is equal to negative 8 plus 24, which is going to be 16. Okay, and so dividing by 8, y equals 2. So my solution is the point negative 2. And remember, if we graphed these, the solution would be where those lines intersect. This one says choose an appropriate method to solve. Many people prefer to use elimination. But again, if you have a variable with a coefficient of 1, it's easy to do substitution. We could rearrange this first equation to be y is equal to negative 6x minus 5. Then plug that in for this y in the second equation, so you have 4x minus 3 times negative 6x minus 5. That goes in there for the y, and that equals negative 7. So 4x, that's going to be plus 18x, and plus 15 equals negative 7. 22x, subtract the 15 across, so that equals negative 22. So again, we have x, this time x equals negative 1. So negative 1 goes there. Then we plug it back in up here. We have y equals negative 6 times negative 1 minus 5, or positive 6 minus 5, or y equals 1. Okay? So I chose, again, substitution because I had one of these with a coefficient of 1. So let's move to the next page of our notes. Okay. Again, use an appropriate method. Well, I don't see a coefficient of 1, so I'm going to go elimination for this one. But I have to make one of these match. Well, if I multiply, looking at the y's, if I multiply this one by 4, I have 12y. And if I multiply this one by negative 3, I have 12y. So let's do that. So that gives us 28x plus 12y, and don't forget to multiply it by this last one. That equals 36. And negative 3 is negative 12x minus 12y equals positive 12. The y's again had to be 0, so we eliminate the y variable. 28 minus 12 is 16x equals 48, and when I divide by 16, x equals 3. So x equals 3. And then I substitute in, so 7 times 3 plus 3y equals 9. 21 plus 3y equals 9. Subtracting 21 across, we have 3y equals negative 12. And so y, when I divide by 3, is equal to negative 4. Now you could have put it in the other equation just as easily. So our y is negative 4. And you check, remember the way you check, is I put these numbers in both of these equations and see if they come out to be true statements. Now, on this one, we're going to solve by elimination again. So I'm going to multiply this second equation by negative 3, looking at the 9. So we have 9x plus 12y equals 3, and multiply the second by negative 3. That gives me negative 9x minus 12y equals 6. Now this is one of those cases, well look what happens. Both of these variables, I eliminated both variables, and so that's 0 equals 9. Well, 0 is not equal 9. That's a contradiction. It's a false statement. And if you end up with a false statement, then the answer is going to always be no solution. Those lines would have been parallel to one another if we graphed them. Alright, again, no coefficient of 1, so I'm going to use elimination. I'm going to multiply this first one. We already have a negative here, so if I multiply it by 5, that will make my x's cancel. So we have negative 10x minus 20y equals 10. Don't forget to multiply it by this last number. That's an easy thing to forget. 10x plus 20y equals negative 10. We just write that one down as it is. Now, negative 10 plus 10 is 0. Negative 20y plus 20y. We have 0 over here. Both things cancel. 10 minus 10 is 0. We end up with 0 equals 0. Well, that's true. Okay. So, again, when your variables cancel, it's either a false statement or a true statement. Your answer is either no solution or it is infinite, or infinitely many, infinite solutions. And in this case, we'll write infinite solutions. Okay? And that is the end of section 2.4.